All right, this is Mr. Smith here. We are in Algebra 2, Lesson 7.7. But before we begin there, I wanted to talk about one problem from the 7.6 lesson that a lot of students had a question on. Okay? And this was a challenge problem, so it's a little bit stretching. But the method that I've taught you will work here. Okay? Now, I would like to contrast that the textbook's approach early on, where they wanted you to rewrite 6 as a power of 3, or 3 as some power of 6. You can't do that here. That's why for the first problems, numbers like 4 through 8, I didn't teach you the textbook method because my method would work on those problems, and the method that I showed you will work on these problems. Okay, what's the method we're going to use? I'm going to take a logarithm on both sides. In this case, I'll take log base 3. So this is log base 3 of 3 to the x plus 4. And this is log base 3 of 6 to the 2x minus 5. Okay. And on the left side, we're just left with x plus 4. It's very nice. On the right side, we're going to use our power rule and bring out the exponent. And this is 2x minus 5 times log base 3 of 6. Now, log base 3 of 6 is not a nice number. It's a mean number. Now, it's a decimal value that's going to be irrational. It's going to go on indefinitely. Okay. So we can choose to multiply by that decimal number. It's like 1.6 or something like that. I don't quite recall. But we could choose to multiply through here and distribute it in. But mathematicians are exact. We want to be as exact as possible. Okay, we're obsessed with being exact. And so instead, I'm going to leave it as a number, but I don't want to have to write log base 3 of 6 over and over and over again. It's so many characters. Right, so instead, I'm just going to make a substitution, and I'm going to introduce some number a that is equivalent to log base 3 of 6. Okay. And so now I don't have to write log base 3 of 6 anymore. I can simply write that out as a. So x plus 4 equals 2x minus 5 times a. And a is just a number. A is not a variable. A is a number. So we're going to treat it like a number, even though I don't know exactly what a is. Okay. So, step 1, distribute the a. So I get x plus 4 equals 2ax minus 5a. And why did I put the a in front of the x here? Why did I put the a in front of the x? Because a is just a number. Where did I get a from? A is the same thing as log base 3 of 6. So instead of writing log base 3 of 6, I'm just going to write a. For now. At the very last step, I'll go ahead and substitute back in log base 3 of 6. But for now, I don't want to have to write it over and over and over again. So here, this is a linear equation. How do I solve linear equations? Pull all the variables to one side, all the numbers to the other. So I'm going to bring this over. So x minus 2ax. The 4 comes over, so this is negative 4 minus 5a. Now I want to combine these, but I can't because I don't know what 2a is. But I can pull out the x. I can factor out the x, so we'll do that. So x, and then this would be 1 minus 2a, which again is just a number. 1 minus 2a is some number. And so if I want to solve for x, the only thing I need to do now is divide by 1 minus 2a. So x equals negative 4 minus 5a divided by 1 minus 2a. And again, a is just a number, so there's nothing to freak out about. I've solved this for x, and the only thing I could do now is substitute back in log base 3 of 6. So x equals negative 4 minus 5 log base 3 of 6 over 1 minus 2 log base 3 of 6. And that is the most exact answer you could give to this problem. Now, I know a lot of you algebra haters out there don't like this approach. So for you, what you would do is you would take, at this point, and you would convert log base 3 of 6 to a decimal. How many decimal places do you want to go? 3 places? Sound good? But now when all is said and done, your answer is only going to be accurate to 1 or 2 decimal places. And if you're using these type of equations to make sure your building that you're building, your skyscraper, is secure from an earthquake, quite frankly, I'd like you to be a little bit more accurate than 2 decimal places if I have to go in the building. Right? So scientists are okay putting a decimal value here because they know how accurate they have to be. Mathematicians say, forget that. I want to be as exact as possible. And this is as exact as possible. Now, for my class, if you'd like to give me a decimal answer and put in a decimal here, I'm all right with that. Okay. Although maybe I'll give you some bonus points if you gave me the exact answer. Okay. All right, so let's look at the approach. How did I solve this? I took a log on both sides. On the one side, I just get x, or I just get this piece here, x plus 4. On the other side, I use the power rule. I bring down the exponent. I now need to address what this piece equals. So I do a distribution. Here's the distribution. Here I bring over the x terms. Here I bring over the constant terms. And here I divide by. This is essentially a coefficient of the x. Here I divide by the coefficient, and I get out what x equals. Okay? And so we'll use this to segue into our lesson on section 7.7. Let me clear this off. And 7.7 is all about writing equations. Okay, so here we are, 7.7. We're writing equations. And these are specifically, I'm going to emphasize exponential equations. Okay. So we're going to write exponential equations. And there are a few other parts to this chapter. There's a regression part that they want you to use your calculator for. I'm skipping that so you can skip those homework problems. And there are some other types of problems in the section that I'm not going to hit. Okay, I'm going to go very briefly through this section. I think there's a few nuggets of value. Otherwise, I'm going to defer for a later class for you. Okay, so you'll learn a little bit more of this possibly later. Okay, so here's the goal. They give us 2 points, and they say there's an equation of a line that goes through those 2 points. Equation of a graph that goes through those 2 points. And it could be linear. We could make a linear line that goes through those 2 points, but they tell us that we want a graph that's an exponential function. So exponential function should look like this. Now, in the world outside of Algebra 2, more than likely what's going to happen is you're going to be given a set of data. You're going to graph the data. It's going to look possibly exponential in nature, or you're going to know it's exponential in nature. And so you use Microsoft Excel or SAP to do some of the functionality for you, and you'll just come out with an equation. All right, so we're going to use technology really to do this stuff outside of here. But this is a good algebraic exercise. So they're going to give you 2 points. One of the points will be either 112, or maybe it'll be 0, comma, a number, or maybe it'll even be 2, comma, some number. But it's got to be like one of these 3. It's got to be something like that. 0, 1, or 2. And this is the one you're going to want to start with. And so we're going to plug these values in. So we plug in 1, comma, 12 into our format. So 12 equals a times b to the first power, which b to the first power, we don't really even have to write that. Okay. And we're going to substitute in the other point. So here's our other information. So 108 equals a times b cubed. Why is it b cubed? Well, the x value here is 3, and so we plug that in for the x value there, right? So what is that called? I have 2 equations with 2 variables. What do we call that in mathematics? We saw these earlier in the year. This is a system of equations. It's not linear. So what? This is a system of equations. Okay. And we have 3 methods to solve systems of equations. We have the substitution method, the elimination method, and the graphing method. Okay, so in this case, we're going to go with a substitution method, and we want to solve the first equation for A. We want to solve the first equation for A. Okay, so this is what you're always going to do. This is what you're always going to do. You're going to solve the first equation for A, and then you're going to substitute it into the second equation. So, in this case, A equals 12 over B. And so this A is the same as this A. So we'll rewrite this. We'll get 108 equals 12 over B times B cubed. And so this part right here is the part that I substituted in. Now, we're going to have to do a little bit of skill here, a little bit of algebra. So I have B cubed divided by B. So this is just 108 equals 12B squared. If I divide both sides by 12, I get 9 equals B squared, and B equals 3. I don't need to consider both the positive and negative case because it doesn't make sense to talk about B as a negative value. It doesn't make sense to talk about B as a negative value. So B equals 3. But remember, I'm looking for an equation, so I need to know what A is. So look back up here at the first equation. If B equals 3, then A has to equal. B equals 3, A has to be. A better be 4. So now I know A is 4. And so the equation of this line is going to be y equals 4 times 3 to the x. And that is not 12 to the x. That's very, very different. Right? The exponent comes first, so it is 4 times 3 to the x power. All right? And that's the equation. We're done. We circle this, we put it on the blank, and we move on to the next problem. All right, so let's try another problem here. Problem number 1. So, we're going to start with this guy, and we're going to plug it in. So 6 equals A times B to the first power, and we'll plug in the other one, 24 equals A times B cubed. Okay. This is a system of equations. We're going to start with the first equation, and we're going to solve it for A. Always. Solve this for A. So when we do that, we get A equals 6 divided by B. And now I see that there's an A in the second equation. Right? So I'm going to replace that A with 6 over B. So 24 equals 6 over B times B cubed. B cubed divided by B is just B squared. So this is 24 equals 6B squared. Divide by 6, 4 equals B squared. B equals 2. If B equals 2, coming back up here and looking at the first equation, if B equals 2, then A has to equal, A better be 3. And so now I know A, I know B, I know the equation. Y equals 3 times 2 to the x. Now, they have to tell us that this is an exponential function. If they don't tell us that, then you don't know that it's in this form, y equals a times b to the x. Maybe this should have been y equals mx plus b. How would you know? So they have to tell us that they want us to use an exponential function, and then it's going to be in the form y equals a times b to the x. We substitute in both points. We solve the easier equation for a, and we plug that into the more complex equation for a, and we solve this. Once I have b, I go back, I find a, and now I have the answer. Okay. This is the extent of what I'm looking for in this section. Okay. Again, so disregard any of the problems that look like this. I don't want you to work on it. I just like to see this algebraic skill. So this concludes my instruction on 7.7. Thanks for your attention. This concludes the chapter. Well done. Good luck and good night or good morning.